Okay. So question number 1, what is the physical state of neon? Okay. At room condition. Okay, what is the physical state of neon at room condition? Anyone who can give me the answer?
Gas.
Yes, very good. The answer is gas, correct. I'm just trying to see why teacher can't write on it. Okay, just hang on. Let me check again. Okay, you guys give me a minute. Okay, what screen do you see? What do you see on my screen?
The one beach.
Okay, that's not what I want. Okay, hang on. Now just give me a minute. Okay, let's teacher change this one. Hang on. Oh, Kidan, I think you're eating, Kidan. I can hear. Okay, do you see this particular screen now?
Yes, sir.
Okay, so very good. The first answer is gas, no problem, because this is group 18. So in group 18, memang it is gas. So for those who came in, Blessed New Year, Blessed 2024, and we're going to start. Hopefully, we can finish by 4:30. Yeah. Okay. What is the type of particles in sodium chloride? Okay, type of particle. We have 3 types of particles. We've got molecule. We've got a very good ion or atoms. Excellent. You can also type in the chat, yeah, if you want. Teacher don't mind. So I can see your answer. If let's say you don't feel like talking, you can write in the chat. Okay, so sodium chloride, one is positive, one is negative. So what do you think my type of particle is here? Ion, very good. Yeah, it is an ion, very good. Okay, because I've got sodium chloride. Okay, let's say teacher asks you, what is my type of particle in neon? What's your answer?
Molecule.
No.
Atom.
Atom, that's right. Okay, correct, it's atom. Okay, neon, if it's atom, it must be by itself, like magnesium. Okay, it's by itself, so it's an atom. And then we look at acetamide. Okay, what is the type of particle here?
It's a molecule.
Very good. It is a molecule. Okay, so this is how you differentiate. Remember, type of particle, always remember missing in action. This is how you need to answer them. Okay, then we go on to the next question. What is the freezing point of acetamide? What's my freezing point here?
80 degrees Celsius.
Correct, yeah? So you must have the full thing, 80 degrees Celsius. If you put only 80, 0 marks. If you put 80 degrees, 0 marks. Okay, it must be 80 degrees Celsius. Okay, the one that teacher ticked is correct. So many students in the past few years, they made that mistake. They so slumbered, go and put 80, and then they lost mark. Okay, so chemistry, the confidence comes in answering correctly, not answering it, oh, I think I've got my correct answer. Sometimes you go in, you're so confident, when you come out, your answer is wrong because they didn't follow marking scheme. Okay, why is there no temperature change from point Q to point R? Okay, this one is just hafaling. Okay, whether you hafal or didn't hafal. So what's my first reason? Wrong. Tanisa, the heat absorbed one is when the graph is going up.
The heat released.
So the answer is actually heat loss to the surrounding. That's my first mark. Okay, so even your answer, okay, heat loss to the surrounding, 1 mark already. Okay, heat loss to the surrounding. Second mark is, if you didn't put the word exactly, is fine, is balanced
The balance by the heat
by
energy
heat
liberated.
energy release.
So can we put liberated too?
Can. when particles
Attract one another.
attract each other to form solid.
Okay.
Now, let's say, teacher, I don't understand, teacher. Okay, this is one question I will tell my students. Even if you don't understand, right, don't worry about it. Just go and memorize it. Because when your graph is going down, this is the marking scheme answer. Perfect, 2 marks. Why you want to bother about understanding something when you cannot understand already? You know this is the marking scheme. If the question asks why in the cooling graph, it is constant. Why is there a constant here? This is your perfect answer. So don't waste time. Okay, so then here's your mark. Okay, we go to question number 2. Okay, question number 2. If you notice, there's actually something missing there, but yeah, we're just gonna ignore that for now, lah. So what is my basic principle used in arranging the elements in the periodic table?
Increasing atomic number or proton number.
Cannot be increasing atomic number or proton number. Too long there.
Proton number. Yeah.
Yeah, so increase in the proton number or number of protons is okay. Okay, increasing of proton number can. Okay, actually number of protons is even better. Okay, so we will accept either both answer, can. Okay, where is my position L in the periodic table? Okay, when they talk about correct, Narma, oh, they'll give me the answer already. Very good. Okay, group 18, period 3. Good, yeah? When they ask for position, I want group and I want period. So let's talk about period. This is period 1, period 2, period 3. Okay, so that is where my L is. So period 3. Okay, and then which group is it in? So if you count group 1, group 2, group 3 until group 12 here, 13, 14, 15, 16, 17, 18. Okay, so it is group 18. Okay, very good. Okay, which one exists like as a diatomic molecule?
E.
Very good. Okay, E. You don't even have to say element E. Straight away, E is fine. Okay. Which one has the same chemical properties?
Element A and element G.
Correct. A and G, yeah, correct. Okay, or if you want to be more specific here, you can say atom A, atom G. But then you must give me a reason. Why? Why do you say they have same chemical properties? And here is when, correct, Avinisha, yeah? Same valence electron is correct, okay? So your answer should either be, you can either put same, okay, wait, not same valence electron, same number of valence electron. Same sister and same number of sisters are two different things. So same number of valence electron. They all have, you want to put one valence electron also can. Same valence electron are two different things. Okay, same valence electron and same number of valence electron means two things. Same sister, same number of sisters, two different things. So make sure you answer it correctly. Okay, so usually teacher likes this answer lah. You just straight away gave me, they have one valence electron. And remember, chemical properties is related to the valence electron. Chemical properties is not related to the proton number or number of protons. Don't get confused. All right. Okay, if teacher want to ask you another question, let me look at this one again. Arrange this from the smallest to the biggest.
Biggest what?
Arrange element A, D, E, G, L from the smallest to the biggest in increasing order.
Yeah, E, D, A, L, G.
Okay, who's that?
Addition, sir.
Jishnu, sorry, Jishnu, I haven't heard your voice in 2 years. Sorry, 2 weeks, sorry, 2 weeks, not 2 years. So I don't really, can't remember. Okay, so Jishnu say E, D, A. Then what do you say, Jishnu?
LG, teacher.
Okay, LG. Okay, can someone raise up your hand if you say, teacher, I really don't know how to do. Okay, teacher said increasing size. How many of you don't know how to do? How do I check? Lama. How come I don't see it? Anyone? Did y'all raise up your hand? I can't see anyone raising up your hand. I mean, don't have to turn on your video. I mean, like, normally there's a button that I can see, right? But how come I can't see anything? Okay. So only one person. Okay, two. The rest of you, you know how to do 3, 4, 2. Okay, so for the sake of those who don't know, teacher teach you. Chemistry has a flag. Malaysia got flag, right? Chemistry also got flag. Chemistry's flag is like this. Sorry, our teacher seems to be having a little bit of flu. Okay, so I hope you can bear with my voice. Okay. Okay. So the chemistry flag is something like this. Nice or not, chemistry flag? And here you can put P, here you can put S, Guan Shina. All right, okay, never mind, that's a joke anyway. So why did teacher do like this? Okay, for group going down the group, the size becomes bigger. That's why you saw teacher did from smaller size going to bigger size. Can you see that? Then on the other hand, horizontally, okay, for periods going across the period, you can see teachers doing it here. The size of the atoms becomes smaller. See from bigger size that you can see here, big going to small. Okay, big going to small. So like Jishnu said just now, okay, going down the period, the size becomes bigger. Going down the group, size becomes bigger. So let's talk about which one is the biggest here. Is G biggest or is L biggest?
G.
Jishnu cannot answer lah, and the others.
G.
G, okay. Who's that?
You got
Yuga, okay. So I start with G is the biggest because going down the group, the size becomes bigger. So that means the biggest for me here is G. Then obviously whatever is in period 3, that will also be big. So I grow across period 3. What do I have here? Teacher has L. So L is the second biggest. Then now I go to the period before that, period 2. I have A, I have D, and I have E. Okay, between A, D, and E, which one is the biggest? I don't want Jishnu to answer. I want the rest of you to answer. If you didn't know how to do, I want you to try it out. Very good. It's A. Which one is the second smallest? Very good. And which one is your smallest of them all? Very good. It is E. All right. So this is how you answer this kind of questions. So they can even ask you, in the trial for the Form 5 recently, they asked, why does the size decrease across the period? So you'll go and find out yourself. Why does the size of atoms decrease across the period? So this is some homework for you. So across the period, yeah. Okay, then you can even go and study about electropositivity. You can go and check about saya dah faham eh. Do you all remember saya dah faham eh?
Yes, sir.
Okay, so which one is more reactive, G or A?
G, sir.
Okay, very good. G is more reactive, and your reason is saya dah faham eh. Okay, for example, if they ask you to compare G and A, you listen to teacher's answer. You listen. I recorded it, so I'm recording it. So even if you cannot catch all that I'm saying, you listen. Okay, the atomic size, the size of atom G is more than the size of atom A. That's your S, saya. D is distance between the nucleus and valence electron of atom G is further than atom A. F is forces of attraction between nucleus and valence electron. You must have the word nucleus and valence electron. Nucleus and valence electron of atom G is okay. Forces of attraction only can be two. It can be stronger or weaker. Anybody, if you write increase or decrease, wrong your answer. So can I ask you, the force of attraction between nucleus and valence electron for atom G, is it weaker or stronger?
Weaker.
Very good. It's weaker. Okay, the further it is from the nucleus, it's weaker. Okay, it's weaker than atom A. Therefore, E here is atom G can donate its electron more easily compared to atom A. I'm a very strict marker. If the question says, compare atom G and atom A, and if you don't compare for me, I give you 0 marks. That means to say, if you say the size of atom G increases, the distance between nucleus and valence electron of atom G increases. You never compare for me G and A, G and A, G and A, G and A, you get 0 marks. Okay, so please take note marking schema, how to answer. Okay, we're only at question number 2. We quickly go to question number 3. What's the chemical formula for copper to carbonate?
CaCO3.
CaCO3.
Huh? Sorry?
Oh,
CaCO3.
sorry, CuCO3.
Yeah, CuCO3. Thank you. Okay, CuCO3. What is the chemical equation for the decomposition? Decompose means dia terurai sendiri. I don't need anything. Dia akan terurai sendiri. And let's say teacher in exam, teacher, I don't know how to get the answer. Or teacher, I really forgot. They already gave you lime water. And then you know there's a carbonate here. That means to say sure got carbon dioxide being released. So I start with copper 2 carbonate, arrow. I will get carbon dioxide. And what is the balance here?
Copper oxide.
Very good. Copper 2 oxide. Okay, copper 2 oxide. So this is my balance equation. Okay. I can guarantee you that calculation will come up. So teacher teach you one time here how to do the calculation. I'm sure you know the formula already. Okay, for your class, I remember it is who and who forever. I know got Rishan.
Narmada.
Narmata.
It's
Okay.
Narmata for
Yeah, again, Narmata and Rishan forever. You all cannot forget, huh? All right. So the first thing they want me to find is they want me to find the volume of carbon dioxide gas when 12.4 gram of copper carbonate is being used. So our teacher write back the formula here. CuO plus CO2. Okay, you're going to get CuCO3. Sorry. You're going to get 12.4 divided by 124, correct?
Yes.
Okay, you get 0.1 mole. Do I want the number of mole of copper 2 carbonate or do I want a number of moles of carbon dioxide?
Carbon dioxide.
Very good. Okay, I want a number of moles of carbon dioxide. So we ratio it. So 1 mole of copper to carbonate gives me 1 mole of carbon dioxide. And from my calculation, I get 0.1 mole of copper carbonate. Sorry for the horrible writing. And 0.1 mole of carbon dioxide. Now I take that 0.1 mole. Okay, I times with molar volume. Always follow what they give. They gave you 24, we take 24. And we will get the answer, 2.4 decimeter cube. Right. Okay, so this ends your question number 3. Okay, question number 4. I just remember that you all actually have the answers with you. Okay, so maybe we go to the questions that you find it hard to do. Instead of teacher going for it. Do you want me to do every question?
No, teacher.
I can do sorts after this. Do you want me to go through every question with y'all, or do you think you want to go to a particular question that you find it hard?
So you can do the particular.
Other questions only, teacher.
Can't really hear you, Yoga. What did you say?
Other questions.
Okay. So what questions you all want to do? Everyone must make sure, by the way, definition is very important. Who can give me the definition of empirical formula? I know many of you would have opened up the book to do it. But can you give me on your own, what's the definition of chemical formula?
The simplest whole number ratio of atoms of each element present in a compound.
Very good. Please don't forget, before the word element must have the word each. Always and always, students always forget the word each element, yeah? Simplest whole number. Even if you didn't put the word whole number, it's fine. Okay? I think the calculation is not a problem. Empirical, not a problem. This one also not a problem. Okay, which one is hard for y'all? Which question is hard for y'all?
So you can try 6 too.
Question number 6. Okay, teacher, go to question number 6. Oh, my favorite question. Very, very good, very good. Okay. So teacher just want to remind you something. Nowadays, okay, even if they put base on table 6 or they don't say base on table 6, when they're asking you for the definition, it must be a specific definition. That means to say it must be based on this diagram or based on this question. Are you following, teacher? Can you get what
Yes,
teacher is saying?
yes.
Okay, so what do you think is the meaning of rate of reaction here? So let's just do this question. I've got zinc and hydrochloric acid. Teacher already know the formula here, the equation. So what is the meaning of rate of reaction? What is the meaning of rate of reaction with just generally? What's the definition? General definition. Oh, tomorrow got chemistry exam, huh?
Teacher, the average product collected per unit time.
Wrong.
A measure of the change in quantity of reactant or product per unit time.
Okay, so that is correct, but it is general. Okay, that is general. So it must be a full sentence. That's why the one who answered earlier on didn't get the correct answer. But now, teacher said based on table 6. So if you listen to Yuga's answer just now, it says the change in the amount of reactant or product. Okay, what is something that I can measure here? How can I determine rate of reaction? They already gave you a hint. The volume of gas. So what is the gas that I'm collecting here?
Hydrogen.
Very good. It is hydrogen, yes. So the answer would be the change. Actually, if I were you, right, I would know that my hydrogen gas is increasing. Okay, I'll put the increase of hydrogen gas per unit time. So the per unit time is always going to be there. Okay, this one is no problem. It is your first part of the answer. Let's say, teacher, I'm not confident with writing increase. Okay, don't put increase lah. But if you hear Yuga's answer just now, it's the change in the amount of reactant or product. Here, I'm not using the reactant. See, nothing here tells me about anything reactant. But here I have 24 minutes, I've got 45 minutes of the hydrogen gas. So the change in the, volume of hydrogen gas per unit time. Does that make sense to you?
Yes, sir.
Okay. Chemical equation, teacher's done that for y'all. Okay, how to find the average rate of reaction here? How does teacher find the average rate of reaction?
Plus divide 2.
Plus divide 2, absolutely wrong.
Oh.
Okay, plus divide 2, absolutely wrong.
So,
Yes.
so you take the volume of gas over, no, you take the volume of the 50 over 24, teacher.
50, where's your 50? 50 over 24. No, 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 no. How do you get 50 over 24? Cannot. You see how many marks we have here? 2 marks only, right? So the answer is pretty straightforward.
Oh, shit. Oh my God.
So can you
24
see?
over 60 seconds.
Yes, correct. So the first one will be 24 over 60 seconds. The second one will be 45 over 60 seconds. Okay, let's all do together. So remember, teacher told you it's listen to teacher. Yeah? Rate of reaction is usually volume over time. Usually. Sometimes can be mass over time. Okay, usually volume over time. Okay, so for the first one here, it is 24 over 60. Okay, everybody tekan calculator. 24 over 60, what do you get?
0.4
Very good. 0.4
cube.
centimeter cube per second. Usually, we always put use per second. That's why you change your minute to second. And then 45 over 60, what do you get?
0.75 cm cube per second.
Very good. In chemistry, your unit is very important. Okay, very, very important. So let's say you just put 0.4 here. So you get no marks at all. Sorry lah, no marks. Okay. Then now we go back to the question. Okay, we understand the question better. Sorry, actually, before you start the question, understand the question better. But teacher did the barley already. Okay, look at the first one. I got 50 centimeter cube, 1.0 mole of hydrochloric acid with excess zinc powder. Then the second one, 50 centimeter cube of hydrochloric acid with excess zinc powder and my copper 2 sulfate solution. What is my copper 2 sulfate solution here? I think I did this experiment or this jumping experiment in class that time when I wanted to finish this syllabus. I put some higher chairs and then I put some lower chairs. Do you remember what is it? What is the copper 2 sulfate there? If don't remember, just put in the group, teacher, I don't remember. So at least teacher will know. Very good. Okay, Jinching says it's catalyst. So remember, in rate of reaction, I have got 4 factors. Whose name? Or Simadev, I think. Simadev can teach chemistry properly. Okay, so S will be for size, C will be for concentration, T will be for temperature, the other C will be catalyst, the last one will be pressure, right? Okay, so here we see that my copper 2 sulfate is the catalyst. Okay, teacher want to remind you, normally whenever I have magnesium and an acid, zinc and an acid, okay, usually, okay, normally it's zinc and acid, my copper 2 sulfate is by catalyst. All catalysts are specific. If I'm using zinc and acid, I only can use copper 2 sulfate. I cannot use any other catalyst. Okay. If I'm doing hydrogenation, I only can use nickel. If I am doing contact process, I only can use vanadium 5 oxide. So all these are specific. So if I ask you, compare the rate of reaction between set 1 and set 2, what's your answer? Which one your rate of reaction is higher? And then the volume of gas is already your hint.
Is it
The
number one, Chuck?
Sorry?
The first one has higher.
Set 2 is higher than set 1.
Correct, very good. You see, here already it shows you that I get higher volume of gas. So that already tells me my rate of reaction for the second one is higher than my first one. Okay, let's go through together. all the four reasoning. Do I have space here? Okay, I'll write down here. Okay, when my size is smaller, my rate of reaction is higher. The next one, when my concentration is higher, my rate of reaction is higher. Next one, when my temperature is higher, my rate of reaction is higher. And the last one, when my catalyst is higher, sorry, not higher. When I have a catalyst present, then my rate of reaction is also higher. Okay, so obviously here with the catalyst being present, very good, you must compare. So set 2 has a higher rate of reaction than set 1. I want to see complete sentence. You cannot do more like teacher. And remember, I think I taught your class rate of reaction can only be higher or lower, cannot say faster. Make sure you're writing in short notes, whatever I'm saying. Then they ask you, based on collision theory, explain the answer. Okay, teacher, how to answer based on collision theory is very simple. Factor, reasoning, and then for catalyst, we only have FOEC. That's it. Okay, so here, what is my factor here? I have a catalyst present, right? So catalyst lowers the activation energy. Teacher put AE because not enough space. And provides an alternative pathway. Did y'all get the F already so far?
So can you repeat that?
Can you see my screen or not?
No, the words are
Oh,
the writing
horrible
handwriting.
writing. Okay, sorry. Catalyst lowers the activation energy and provides an alternative pathway. Alternative pathway.
Okay.
Pathway. I'm trying to get a writing pad so I can improve on the writing. 2024. Improve writing on the computer. Resolution. Okay, anyway, let's take a break. No, I will take a break after this. Reasoning. What's my reasoning here? Why do I want to lower the activation energy? Was there anybody that day who couldn't do a higher activation energy? Was there anybody who couldn't jump high? You all can't remember, isn't it?
I think it was me, teacher.
Oh, Zafran and Harshana. Okay. All right. So when I want to make it lower, right, I put the catalyst is because then I want Zafran and Harshana to be able to overcome the activation energy. Okay, so then my second sentence will be more colliding particles. You think of Harshana and you think of Zafran. Jerry, sure or not, Jerry? You're bullish, another. Oh, Rishan. Jerry, you started first, Rishan. Oh my gosh. Okay, fight lion. Okay, more colliding particles are able to achieve the activation energy. Jerry, you better stop bullying him, Jerry. After you don't grow even higher than lagi teruk. Okay.
So teacher, so you can write this rather than writing to overcome the force of attraction.
Huh? Why you want to talk about force of attraction here?
Oh, I don't know. I just heard the force of attraction. So
No need. More colliding particles are able to achieve the activation energy. Jerry, I will go against you, Jerry. I will say he will grow. Okay, but I didn't say which, we are not comparing which way he will grow. Okay, we're not talking about height or anything else. He can grow in so many other ways. Yeah. All right. Okay, let's finish my sentence before Jerry have to come back again. Okay, FOEC. Okay, the FOEC between who and who? This one is very important. You must know. Okay. What is my ionic? Very good. Tanisa is very good, but Tanisa wrong also. It's not zinc and hydrogen. It's zinc atom and hydrogen ion. In between zinc atom. I don't know why the people are so particular for you all to have the word atom. Zinc atom and hydrogen ion. But I think I remember stressing it in class already, right? Did I stress this in class? The word atom?
Yes, teacher.
All right, thank you. So the frequency of collision between zinc atom and hydrogen ion is higher in which set? You cannot say particles. No. So sometimes they will, when you're doing FOC and FOEC, you need to say the name of the particle. Okay, so it's higher in which set? In set 2 or in set 1? Very good. In set 2. Can I
Set
give
2.
you all marks for this? For the last mark?
No, teacher.
Cannot, because I didn't compare. It's higher in set 2 than set 1. Correct. Then this is correct. Okay. So I want to just do the FNR for all the, yes, Anurag, you raise your hand.
Teacher, just want to ask, what is FOEC?
Frequency of effective collision.
Thank
Never
you,
mind.
teacher. Thank you. I
That's
thought
why
it
I
was
want
force of electro something.
No, that's why I wanted to have the class at 3 o'clock. Because maybe when I end it by 4 something, you all still got the whole evening to study some more. Okay? Okay. Let me just do for you because I can't remember, I don't know what's coming up for the exam. I really didn't look at the paper, so rushing for time this time. Okay? So I am as clueless as you, okay, on what's coming up. I cannot not say clueless, I can't remember. Huh? Okay? Let's say teacher's doing the size factor. Okay, so if I'm doing the size factor, so your factor sentence will be the size of, let's say we're doing zinc, size of zinc in set 1. All these are examples. I'm just teaching you how to answer is bigger than set 2. Teacher's just giving you the way to answer. Okay, when I talk about size, what's my reasoning? Oh, Vishen, sorry, no, it's not zinc and chloride. Vishen, you're wrong. Okay, so I backtrack first. I answer Vishen's question. In order for you to know what are your particles, okay, so do it here. Okay, is you need to write down what is your equation. And then after you write down what's your equation, okay, and then you are going to find out which is my solid, liquid, and gas. And after finding out which is my solid, liquid, and gas, I just put it back again. So zinc is my solid, I write it back again. Hydrogen gas is my gas, I write it back again. And then I am going to break it up. Okay, HCl I can break up to H plus and Cl minus. And zinc also, zinc plus and Cl minus. Okay, here 2 Cl minus, here 2 Cl minus. Now, which one before and after arrow? It is the same. Cl, right? All can see that, right? So they're just going to cut Cl. It's just like when Coldplay came to Malaysia, or when there is a football match going on. I think yesterday there was a match, last night. Man City against who? Okay, never mind.
No, I thought it was Fulham versus Arsenal, so I think so.
Oh, sorry lah, can't remember who played against who lah. But even though you were there or not there, whether Coldplay was having their concert and you're there or not there, it still goes on. So You are like that spectator. And whether you are there or not, it still goes on. So chloride, we don't care about it because it's just a spectator. Whether it's there or not, reaction still goes on. So I'm going to rewrite whatever that I've not cancelled. So here will be zinc plus 2H plus, arrow, I get Zn2 plus H2. So then I'm answering your question, Vishen. What are my particles? And it's always the reacting particles. So it's zinc and hydrogen ions. So we always get our reacting particles from the reactant. Okay, they're always from the reactant. Vishen, have I answered your question, Vishen? Okay, I'm assuming he's going to say yes. And I'm assuming he understands what I said. All right. Okay, so to go on here again. Okay, I wanted to ask you, what are the factors? Okay, when the size of zinc is bigger. Oh, I think smaller size better. Lah. When the size is smaller, then what happens? What's my reasoning for the size factor? You are sitting for exam tomorrow, not teacher.
Total surface area exposed to collision increase.
Yeah, someone said something and the answer is correct, but I can't hear you very well.
The total surface area exposed to collision increase.
Okay, so total surface area. Okay. Of zinc is bigger. Total surface area is bigger. The word must be bigger. When your size is smaller, your total surface area is bigger. Okay, in set 1 compared to set 2. Now I can't hear, I don't even remember who's the girl who answered just now. Who was it? Narmata, sorry, Narmata. You can't really hear the sound. Okay, I apologize. Okay, so total surface area. Okay, let's say I'm doing my factor concentration. So I see Jeremiah's answer is total surface area per unit volume. Okay, per unit volume is for the factor of concentration. So it's the total surface area only. So Jeremiah, you mix both together. Okay, let's say in the factor of concentration, so let's say I say my concentration in experiment 1 is higher than experiment 2. Okay, concentration of what? Cannot just put concentration. Now let's say teacher say my concentration of hydrochloric acid in experiment 1 is higher than experiment 2. So then, what's my reasoning? Okay, like my hydrochloric acid here. This one is 1 mole. Here teacher put 2 mole. Okay, let's say got no copper 2 sulfate. What is my reasoning? When I'm doing concentration, remember, here teacher got hydrogen ions. So when teacher got hydrogen ions, that means if I got more hydrogen, concentration, the number of hydrogen ions per unit volume in experiment 1 is higher than experiment 2. I'm just giving an example. This comparison is just an example of an experiment. I'm just teaching you how to answer the first part. Are you following what teacher is saying so far?
Yes, teacher.
Okay, so in exam, it will be, if you want to answer this question, 5 marks, it will be factor, reasoning, FOC, FOEC, ROR. And only the F and the R is always different for each. FOC and FOEC, teacher always told you they are copy paste. Okay, and then your ROR, you compare only. Okay, let's go to temperature. If teacher is doing temperature, let's say I say my temperature in experiment 1 is higher than experiment 2. Okay, what is my reasoning? What's my reasoning for temperature?
Is it the particles collide more frequently?
Yeah, so the kinetic energy of particles in experiment 1 is higher than experiment 2. Okay, particles collide more. Then you just carry on with your FOC, FOEC, and ROR. Okay, so teacher covered completely your ROR if they ask collision theory. Okay, remember if they ask you collision theory, you must start with factor, reasoning, FOC, FOEC, ROR. Your FOC and FOEC, you must tell me between who and who. How do I find out between who and who? Go and write down the chemical equation, get the ionic equation, then this is my reacting particles. Okay, teacher covered rate of reaction extensively. Does anyone have a question on rate of reaction that you want to ask me?
Not sure.
No, we go to question 7. Do you all need help or can you answer?
And
You tell teacher, does anyone need help for question 7? Oh, need help. Okay, let's go. Alloy Y, Y is used in metal production. Okay, what is the name of alloy Y? And what is my atom X? So what do I use for metal? Copper, right? Yeah, copper alloy only got 2. One is bronze and one is brass. Okay, brass is usually the musical instruments and everything. Okay, all right. So bronze is always in the metal production. Okay, and then for bronze, you must remember brochuti. Okay, bronze is copper and tin. Okay, bronze is copper and tin. So here the smaller ones are the copper and the bigger ones are the tin. Okay, so the name of the alloy is bronze. Okay, and what is my atom X? My atom X is tin. Any question? Okay, let's say they ask me brass. Okay, what is the atom X in brass? What's your answer?
when I can answer. Zinc.
Very good. It is zinc. So how to remember? You remember brass. Or maybe brass. Okay, it sounds weird and looks weird. Okay. Cobras. You just end it with a Z. Okay, so copper and zinc. Okay, then you will get brass in it. All right, so remember when you have zinc, then you will get brass. Now, why is alloy Y more suitable in metal production compared to copper? Why? And I've taught you the way to memorize also. What is the way to memorize? I've given you a hint. Oh, did I teach you this?
No, teacher. Cikgu Bashira taught us.
I don't know if she taught you D, D, D. Did she teach you D, D, D?
No.
Okay, so the first D is different sides. Okay, all of you writing down, huh? The second D is difficult, sorry. The second D is disrupt. Disrupt the orderly arrangement. And the last D is difficult to slide. So I'll teach you how to write in a sentence. So you don't have to worry. Okay? Okay, so teacher's going to teach you the first one first. First D, different size. So I'm going to write here, alloy Y has atoms of different sizes. Teacher put DIFF, so I don't have to waste time. Okay, atom of different sizes. I have one mark here already. Okay, now what does this atom of different sizes do? Okay, I know that my bigger atom here is the tin atom, right? So I can put here tin atom disrupts the orderly arrangement of tin is disrupting the orderly arrangement of who? Of what? Of which atom?
Copper.
Very good. Of copper atom. Okay, of copper atom. You got your second mark already. Okay, then what was my third point? I already told you all. D. Okay, different size, 1 mark. Disrupt the orderly arrangement, 1 mark. The third mark is difficult to slide. But most students will lose mark at the third mark. Because you must say first, when force is applied. Okay, when force is applied, the atoms do not slide easily. Okay, the atoms in the alloy do not slide easily. Okay, so here, why the teacher need to put the word when force is applied? How many of you, when you're standing straight by yourself, you can slide? I mean, you don't slide, right? I mean, unless you're super duper thin and you're gone with the wind kind of thing. Okay? But normally a normal atom or even a human or whatever, okay, when you are by yourself, you cannot slide easily. But when you put force on you, then it will slide, the atoms will not slide easily. So if I have just copper only, if I just put a force on you, all of them will slide easily. However, if I have copper, tin, tin again here, copper, do you think that my atoms here can slide easily? Can or cannot?
Cannot, sure.
Cannot, yeah? So memang cannot. So this will be a marking scheme answer. Okay, this is your,
Sorry, Chair, I have a question.
Yeah.
Because it's comparison question, do we have to say after every sentence compared to
No.
copper? Okay, no, thank you.
no. Okay, why is it more suitable? Because if you look at the last answer, okay, look at the marking scheme. Why is it more suitable? So it does not, when force is applied, it does not slide easily. Maybe then at the end you can put compared to copper. But even if you didn't put, we already know what you are saying. Because you're already talking about alloy.
Could we
Okay, the
also
alloy.
mention that it's shinier and that
No,
it
that
doesn't
one you
rust?
get 0 marks.
Okay, thank you, Chair.
Totally 0 marks then. Okay. These are some things about glass that even teacher can't help you. You have to go and really read up about it. But I know that I have told you there are 4 kinds of glasses. Okay. With your class, whose name did I use for the S? This is Fuyo. Eh, I didn't teach your class this, is it?
No, Chair.
Okay, so this is
I can't remember it, Chair.
Yeah, so this is a short form I give it all my students. I'll go like Fuyo. Okay, who in your class the name starts with S besides Simadev?
Arvind,
Okay, Fuyo, Sharvin, Boss La. Okay, and the first one is Fuse glass. Okay, and that's the simplest of the glass that you can find. Okay, and I usually use it for telescopes. Okay, I look far up, I look at telescopes. Then I've got the next one, which is Sharvin, okay, which is soda lime glass. Okay, and soda lime, the name already tells you, I must have sodium, I must have lime. Okay, lime is calcium carbonate. So soda lime is, okay, think of Sharvin. Sharvin is like kind of want to be cool all the time. So it's always looking in the mirror. Is that true about Sharvin anyway?
Yes.
Okay, he likes to look in the mirror. So one example of soda lime is mirror. Then Boss is borosilicate. Okay, and then you think about Sharvin in my lab. Okay, and he breaks all my lab apparatus. Okay, and then last one is lead crystal. Okay, lead crystal, and that would be all the beautiful decorative stuff that you see. Okay, so again, this chapter 8, you must go back and read. It's not like teachers simply tell you and then I can give you the answer. No, you must go back and read as well. Not go back, you're already back at home. You must read up, then you're able to answer the question. So they can ask you questions like similar properties, okay, between gas R and gas T. You have the answers.
Teacher, is
So,
it very
sorry?
sorry, teacher, is it very likely for them to ask the composition of the glass?
No, they will never ask you the composition of the glass, as in how many percent, no. They will never ask you that, so don't worry about that.
Okay, teacher.
Okay, right. So this one, I personally want you to read up first, and then I want you to answer this question because this is just mere reading. I've already taught you some ways to memorize. Okay, and I think in chapter 8 also you've got what is it called? Reinforced concrete. Have you all read that already?
Yes.
Okay. This comes under, what's my title for this?
Composite material.
Correct, thank you. Composite material is something like alloys. By itself is not good. I need to mix things together. Then only it's better. Simadev and the gang, Simadev, Kuvan, Jega can tell you about it, right, Simadev?
For sure, Chair.
All right, okay, let's go on. Okay, so this is a story that I want to give you an example. So in composite material, I've got 5. So the first one I want you to memorize is roti canai. Okay, reinforced concrete. So these are some examples. Okay, you are so hungry, you want to go and eat something. So you want to eat roti canai. It's reinforced concrete lah. Then how to get there? You are thinking of to yourself how to get there. So you need to take a bullet train there. So you think of superconductor. Okay, because bullet trains got superconductor. Again, teachers giving you the different types of composite material. I'm giving you a story. So now you're in the bullet train and you can't wait to go to the place that has roti canai. Okay, then your next one is you suddenly see a motorbike. Okay, you see a motorbike and okay, I know the story gets weird. It's a motorbike and a bullet train. And you go on the motorbike, okay, and you put on your helmet. Okay, what's that? Your helmet, what's it called? What is it made of?
Glass fiber.
Very good. Or fiberglass. So fiberglass, you put on your head. This is for your helmet. And then you feel so lonely. You feel that, I need to call somebody. So you call your girlfriend. Okay, and then you talk to your girlfriend. Okay, what are you using?
Optical fiber.
Optical fiber. Okay, and then you feel that you're already on the motorbike and you want to look cool. What do you pull out?
Photochromic glass.
Yeah, your photochromic glass. Okay, your shades. Alright, so these are the 5 composite materials that you have. You cannot tell me after today you cannot remember them. Okay, I've created a very nice story for you. Now you go and you go and find out what each of them does. Anybody of if the exam tomorrow comes out this one and you cannot answer the question, teacher will shoot you. Okay, I gave you a very nice story here. Okay, question number 8. Question number 8 can do? If can do, no need to waste time. If can do, you can go and try on your own. Which one you cannot do, the teacher wants to do? Yes, no, maybe so? Okay, you all also don't know what you all know. Okay, so never mind. Okay, have you all tried question number 9 or not?
Yes.
Yeah? You need to answer, teacher. If not, what questions do they ask for composite materials? They can give you, so composite material chapter 8, they can give you a picture of superconductor and then ask you, what is this? What are some of the special characteristics of it? Or they can give you a picture of a uh, uh, helmet and then ask you what is it made of. Okay, or they can ask you why must you, they can give you a scenario. Here normal concrete, here is a different kind of concrete added with different things. What are the different things? Why do I need to use reinforced concrete? So these are the questions that they can ask. I don't think they will give you a full question on composite material, maybe half composite material, maybe half glass, like the previous question. They can ask you something like that. Hope that helps you, Ira. Okay, so if you didn't try the questions, okay, it's a bit hard to teach you all, okay, because it's only teacher trying to give you the answers and you didn't try. But I'll see what I can do to make up the time now. We'll try and see. Okay, let's move on. What is the type of particles for substance R? Okay, let's look at R. R has a very high melting point. Woo! And I can conduct electricity in my solid and molten state. What do you think is R? So this is a chapter on chapter 5. Again, I think Cikgu Ira taught you. Very wrong answer, Rishan. So, okay, thank you for showing to me that actually. So you've got 3 bonds. Sorry, you guys, I know you're trying to say something, but I can't hear you. I've got ionic bond, I've got covalent bond, and I've got something called a metallic bond. A metal is the only one that can conduct electricity in a solid state. Okay? So what do you think is R? A metallic bond, isn't it? Okay, that's why it has a very high melting point. Okay, then teacher want to ask you. I give you an example of a metal. Metal is magnesium, yeah? So what is the kind of particle I can find in metal? You must try, you must think. Teacher cannot help you if you don't think. Very good. Okay, so Tanisa, correct. Vishen, you are answering the question wrongly. Type of particle is always missing in action. So the answer is actually atom. Okay, so it is actually an atom. Okay, and then why can it conduct electricity in a solid and molten state? Why?
Because we have free of delocalized electron.
Very good. Okay, the most important thing is, the most important thing is you all must remember it must have free moving. Okay, I want to ask you, can I put free moving ions? Can I put here free moving ions, or do I need to put free moving electrons?
Free moving electrons.
Free moving electrons is the perfect answer. Okay, because in a metallic bond, yes, I got ions, but it is the electrons, okay, that are delocalized and are allowing it to conduct electricity. Okay, so 1 mark here, 1 mark here. Okay, now we're going to compare P and Q. Okay, you tell teacher, P is what? What do you think is P? Ionic bond or covalent bond?
Covalent.
Very good. It is a covalent. Teacher, why covalent? You look at the melting point, so low, and I cannot conduct electricity. Remember, I told you if it's bad, it's a bad boy, it's a covalent bond. You look at the next one. I cannot conduct in solid, but I can conduct in molten. That's a good boy. Okay, so a good boy is an ionic bond. Okay, and not just boy, okay, girl also can. Huh? Okay, so they ask you to compare substance P and Q and then explain the difference in the following properties. Okay, I just want to take out the answers for y'all. So while I do that, okay, I'm going to ask you to take a 1 minute break. And the same time as you're taking the 1 minute break, go and drink water, go and take whatever. I want you to put in your chat here, what are your resolution for the coming year? Okay, what is one resolution for this new year? I just want to go print out, take out the answers for y'all so that y'all can see the marking scheme. You can put in the group, yeah, one resolution for this year. And you give teacher a few minutes. Huh? Oh, okay. Yeah, I see some answers from you. Oh, page 24. Okay, hang on now. Okay, let me just, page 24 of the question or page 24 of the answer, Namata? Yeah, page 24 of the question. Okay, so I've got only 2 people telling me what they want to, their resolution for the year. The rest of you haven't thought yet, is it? Okay, for teacher, it will be hoping that all of y'all can do well tomorrow for the paper. Did y'all study during the holidays? Or did y'all mess around?
Yes, sir.
Studied,
Yep.
Okay, who did not study? Better tell now. And who is hoping Panchina is going to give tips? Please, teacher don't give tips, okay? Who did not study? Angkat tangan. Okay, nobody is 50-50, okay. Oh no. Okay, now let's try to show you all the answers, Hang on. Okay, can you see the answer screen on my page? I'm using the answers so that you all can understand better. Here you're comparing melting point and then the reasoning. Okay, so the melting point of Q is higher than P. Okay, all of you can see that very clearly. If I switch, what do you see on your screen now?
The question, sir.
Very good. So what they did is they compare. Okay, they compare first the melting point. So here the melting point of Q is higher than P. Okay, so that's already 1 mark. Now, why? Why is my melting point of Q higher than P? What does Q have that P doesn't have? So the marking scheme is P consists of molecules, okay, held by weak intermolecular forces. If you cannot say van der Waals, it's okay. So P, my melting point is so low because I'm held by weak van der Waals forces. Q consists of ions held by strong electrostatic forces. Okay, so my Q, I have strong electrostatic forces. You must remember the word. You must forever and ever remember the word electrostatic forces. When I have strong electrostatic forces, I have more heat energy. And you cannot put more heat, must have the word, or cannot say more energy, is more heat energy needed to overcome the strong ionic bond in Q. So this is a famous 4-mark question. Why is one melting point higher than another melting point? The weak melting point is always held together by weak van der Waals forces. So I don't need a lot of energy for it. But the one that is higher melting point, I have strong electrostatic forces of attraction. So I need more heat energy to overcome the strong ionic bond in Q. Then they ask you to compare. Why some can conduct electricity, some doesn't conduct electricity? How come? And if you notice, here is ions. So which means to say I have ion, this is ionic bond. So I got ions here, I got no ions here. You must talk to yourself during the exam. Okay, so P, the one that is covalent, cannot conduct electricity at all states. You must explain your observation. Must explain. Okay, P consists of neutral molecules, or P does not have free moving ions. You cannot write the word electrons here. Okay, Q pula, Q cannot conduct electricity in solid, but it can conduct electricity in molten and aqueous. Why? Because in solid, it is held in fixed position. But in molten and aqueous, they are freely moving. Okay, the ions, make sure you mention. Or you can say they are free moving ions. Some students wrote free ions. The ions are not free. Some students wrote moving ions. The ions are not moving. It's free moving ions. Must have the 3 words to it. Okay, then you get full marks for that. Do you understand what teacher said? Can you get what teacher is saying here?
Yes, teacher.
All can. So this is a very important question, and I want every one of you to actually try this. Okay, this is very important. Yeah, so teacher already put asterisk here. Important. Go and learn how to write the ionic bond. Go and learn how to write the covalent bond. Okay, both of this is very, very, very important. Okay, teacher wants to see how many of you actually tried this question. Okay, which one is the covalent bond here? Which one do you think is a covalent bond here? Which one will form the covalent bond?
C and O.
Very good. C and O. Perfect answers. Okay. So C and O will form the covalent bond. Okay, can someone tell teacher what is your first sentence here?
Carbon has an electron addition of 2.4.
So you don't even get 1 mark. Okay, you don't even get 1 mark here. He said carbon has an electron arrangement of 2.4. 0 mark. You must have carbon atom has an electron arrangement of 2.4. Okay, teacher maybe I will give you 1 minute. Okay, 1 minute to try out the question. Okay, teacher wanted to try for teacher covalent bond. Ionic bond you can try also, try for teacher covalent bond. Do you all try? Okay. So teacher do both together with you all. Let's do ionic compound first. Okay, ionic compound, which one is it? If you want to get an ionic compound, which one will help? Which one is your ionic compound?
MgNO.
Okay, MgNO. Teacher don't want to see just Yoga only giving the answer. Teacher want to hear all of you. At least I know you're trying. Okay, very good. MgNO. So how are you going to start your sentence? At least 4 marks here for ionic bond. What's your sentence like? What's your first mark like? Okay, electron arrangement of atom or magnesium atom is 2.8.2. The electron arrangement of atom of oxygen atom is 2.6. This is your 1 mark. Are you all writing down as teacher is writing down?
Yes, sir.
Okay. So what does your magnesium atom do? Magnesium atom is going to donate how many electrons?
2.
2 electrons. To what? To form?
To form ion.
Mg2 plus ion, isn't it? Very good. Mg2 plus ion and achieve stable octet electron arrangement. Must mention that. Okay. Now is donating is 2 electrons to who?
Oxygen.
Okay, very good. Okay, to oxygen atom. So teacher's going to add on here, oxygen atom. Normally, one ionic compound, ionic bond question is 10 marks. Now they're already making it 4 to 5 marks. So we must be wise how to answer. Okay, the next one. How to get the next mark? So magnesium is donating. What is oxygen doing?
Receiving.
Very good. Okay. So 1 magnesium atom, 1 oxygen atom receives how many electrons?
2.
2 electrons from who? From magnesium.
Magnesium.
Okay, to form what?
O2 minus.
Very good. To form O2 minus. And what do they want to achieve? As actually, the most important thing they want to achieve, what?
Stable octet electron arrangement.
Stable octet electron arrangement. Last but not least, your last mark. Okay? Mg2 plus and O2 minus are attracted to each other. Ionic bond. What are the forces then?
By strong electrostatic force.
Very good. By strong electrostatic. Sorry, forces of attraction. And what are they going to form? What bond are they going to
Ionic.
form? And form
Ionic.
an ionic bond. What is the ionic bond? You don't even get full marks here. What is your ionic bond here?
MgO.
MgO. You get 4 to 5 marks for this. But it's not complete, right? We want to get 10 marks, right? Now, how to get the 10 marks? Okay, let's say we got 5 marks here. Lah. How to get another 5 marks for my covalent bond? Okay, who wants to try the covalent bond? Okay, we do together with teacher. Okay, so this is the covalent bond. Just now, Yuga already gave me. Carbon has an electron arrangement of 2.4. Then the other one? Oxygen, right? Okay, oxygen atom has electron arrangement. Teacher make it shorter of 2.6. 6. Okay, 2, oops, 2, oh, something's 2.6. Oh, teacher can't write already. Okay, electron arrangement of 2.6. What's my next sentence? Wait, my battery died on me. Oh, who's on my page writing here? Was it me? Delayed reaction. Let's see. No, I still can't write. Okay, never mind. What's my next sentence? What should teacher's next sentence be? Okay, clearly, some of you all have not been studying during these holidays. Okay, how many atom Qs are going to share electron? Look at your atom, your carbon atom, sorry. Look at your carbon atom. Carbon atom has 2.4. How many more does it need to become stable?
4.
Very good. So write down 1 carbon atom. You write down, now teacher can't seem to write ready. My pen's not working. Okay, 1 carbon atom shares 4 electrons. Okay, it's sharing 4 electrons with how many oxygen atoms? This one is very important.
2.
2 oxygen atom.
Very good. How many of you don't know? Teacher, I don't know why the oxygen got 2 and the carbon got, why the oxygen must be 2 and the carbon is 1. How many of you don't know? Thank you, Simadev, for writing. How many of you don't know why? All of you know why it's 1 and 2? Confused a bit. Okay, I can't seem to be writing on my screen. I have no idea, my pen suddenly so long didn't work, and then today I'm using it so much. It's confused to the max. Okay, so all of you write down carbon, and then you put 2.4 at the bottom. Okay, teacher try to write here. Carbon, I'm using my finger here, 2.4. Oxygen is 2.6. Normally, if it's ionic bond, teacher always say darab silang kan? And you put the charge on top, right? In covalent bond, is different. Okay, 2.4. How many more to become stable?
8.
Oi.
4. Sorry, 4.
Yes, okay, so the 4 I put on top. Oxygen 2.6. How many more to become stable?
2.
2. Okay, and then now teacher's going to cancel all this. Now I darab silang. I put back my carbon, I put back my oxygen. What number do you see on top of the oxygen? 2, right? So I put 2 here, and then I put 4 here. And then, of course, C2O4, teacher can minimize it. I can make it C1O2. So now, do you understand why my carbon has 1 and my oxygen has 2, Ira? Okay, so that is the way, if they ask you any covalent compound, any whatsoever, this is the way to answer. Okay, let me just see if I can erase this. Okay, so teacher gave you the first mark, and then Simadev is helping me to type out the second one. Thank you, Simadev. So one carbon atom shares 4 electrons with 2 oxygen atoms. Okay, then why? Why am I sharing electrons with 2 oxygen atoms? What do I want to achieve?
So yeah.
Very good. Carry on, type it out. To achieve, so yeah. Just giving you perfect marking scheme. Perfect. So if you don't know what you're missing, you don't know what you're missing. Okay, to achieve soye. That whole thing must be one sentence, yeah? To achieve soye is together with 2 oxygen atoms. Right? Okay. Then what's my next sentence? So this one here, can you all see teacher's pencil here?
Yes, sir.
Okay, that is my mark number 1. What Simadev wrote was my mark number 2. Mark number 3. Okay, everyone writing down mark number 3. Carbon atom contributes. A carbon atom contributes 4 electrons for sharing. You must mention that. Last year SPM, If you didn't write like this, no marks. So carbon atom contributes 4 electrons for sharing. Must have the word contribute for sharing. While oxygen atom, you continue the sentence for teacher. Oxygen atom contributes. You tell, oxygen atom contributes how many electrons for sharing?
2.
2 electrons for sharing. Simadev, are you writing or Simadev?
Yeah, sure.
Thank you. So I repeat, carbon atom contributes 4 electrons for sharing, while oxygen atom contributes 2 electrons for sharing. That's your third mark. What is 3, 2? Jeremiah?
Typo, Chair.
Really? Are you timing me to my 4:30, Jeremiah?
Yes, Chair.
Okay, you want to leave? You can leave.
No, Chair, no, Chair.
I
Yeah,
think we'd rather it longer, Chair.
Sorry?
I think we'll be very grateful if it's longer, Chair. We don't have an issue with that.
But the rest were here longer than you, so I don't know whether they will appreciate appreciate that. I don't know if they want that, but teacher don't force anyone lah. Jerry, you're in big trouble lah, Jerry. I forgot to turn off Zoom talking to each another. I'm sure Jerry meant this for someone else, right, Jerry?
Teacher, no, I wanted to say 2, then I actually pressed 3.
My toes also laughing, Jerry.
No.
Okay. All right, let's move on. Let's move on. Let's see how to get my next mark. People all want to concentrate. Jerry, see, you make me go longer. Class tomorrow, make sure you beat Jerry, yeah? Okay, what's my next mark? Okay, my pen is, I'm able to write ready now, Simadev. Okay, this is number 2, this is number 3. Okay, number 4. So 1 carbon atom and 2 oxygen atom. Remember, this is marking scheme answer. It's up to y'all whether y'all want to take the time to answer it properly. Okay, 1 carbon atom and 2 oxygen atoms shares electron. That's it. That's your 4th mark. Your 5th mark. Okay, they are bonded with each another with weak van der Waals forces of attraction. Okay, to form QR2. Right, to form CO2. Okay, to form CO2. Okay, if y'all want to take a picture of this, y'all can, so that y'all can actually memorize it later on. Okay, if y'all feel that y'all want to, okay? Okay, sorry, I think Namata is telling me page 24. Okay. Yes, Namata. You want this question, is it, Namata? Don't know how to do this? Sorry, Namata. Now only I'm getting to it. Okay. Before that, before going to Namata's question, okay, this is an acid question. I think y'all should be able to answer. Okay, teacher took longer for this question because I didn't get a chance to teach you. So because I didn't get a chance to teach you, therefore I have to take a longer time to explain it to you. Now, an acid question, name acid HY. What do you think acid HY will be? I want to do very quickly with you. What is acid HY? It has a pH of 5. What is pH? Yes, correct. It's ethanoic acid. It's ethanoic acid because it is a weak acid. Now, when they ask you why does the pH value different, okay, you listen to teacher's answer, but I think marking scheme also should have it. Simadev, I'm so sorry, you have to take out your answers. If not, it will follow us wherever it goes. Okay, so you look at how it answers. It's a very simple answer. Nitric acid is a strong acid, ionizes completely in water to produce a high concentration of hydrogen ions, 1 mark. Ethanoic acid, weak acid, ionizes partially in water to give me low concentration of hydrogen ions, 2nd mark. The higher the concentration, the lower the pH value. This is my 3rd mark. Okay, so this is how you need to answer. If then the question asks you, why one got a reaction? Why suddenly here lime water turns cloudy? Why here got no reaction? They always go back to the solvent. One solvent is water. One solvent is an organic solvent. So you tell teacher, the one that has the reaction, which is solvent X, what is my solvent there? Water. Very good. Okay, excellent. Okay, and my solvent Y is a solvent that you can name anything. Propanol, you can name tetrachloromethane, anything. NON. Okay, propanol. Okay, so it depends on what you want to name it. Okay, now explain the difference. Why water can, why propanol cannot? Very simple answer. Okay, hydrochloric acid will ionize in water. When I have water, I've got the hydrogen ions. And this hydrogen ions is the one that shows the acidic properties. Therefore, when my HCl reacts with my calcium carbonate, I will get the carbon dioxide gas. Now, if my HCl is in propanol, it cannot ionize. No way. So if I cannot ionize, I cannot show my acidic properties, I will get no reaction. This is a famous question. Nowadays, they like to ask you, explain the difference. They already gave you the observation. You need to give the inference. Why here I got a reaction? Why the other one I don't have a reaction? This is a very famous way of asking questions now. Explain the difference. Okay, now we go to Namarta questions finally. Okay, Namarta must be like, whew, thank God, teacher. Okay, I've got a salt P reacting with a sodium carbonate. Okay, salt P reacting with a sodium carbonate. And then they ask me what is my Q and what is my P plus. Let's do this question together. When I heat up straight away, okay, I've got 1, 2, 3. When I have 3 products, what must my salt P have?
Nitrate.
Very good. I must have a nitrate salt. Okay, I must have a nitrate salt. So here will already be a word nitrate here. Now then you look here. When teacher has salt P with sodium carbonate, teacher get lead 2 carbonate. So what do you think my cation will be in salt P? Because suddenly out of nowhere, I got lead. Very
Lead
good. Very good. So my salt P is lead 2 nitrate. Do you all understand how to get that answer? How to get lead 2 nitrate? Narmata, you being with the one that is was asking the question, do you get this, Narmata? Okay, never mind. So even as we get lead 2 nitrate, okay, teacher is going to do this here. Okay, you tell teacher, when I heat up a nitrate, what must I get? What's my first product here? What's my solid Q? You know I've got a brown gas. What's my brown gas?
NO2.
Very good. NO2. What's my colorless gas here?
O2 or
Very good.
yeah, O2.
Very good. O2. Very good observation. Okay. And what do you think is my product here?
Is it just lead?
No. Very good. It's
Lead
actually
oxide.
lead 2 oxide. Beta, all the questions too? Why don't you take a break for a while? Okay? So what I told you all how to balance this. I've given you a formula to balance this. Okay, so you need to remember 22, 22, 41. Puan Shina's birthday is on the 22nd. 2 plus 2 is 4. There's only one Puan Shina you see in this whole wide world. Hopefully. So here will be 2, here will be 2, here will be 4, here will be 1. Why you needed to do that? Because later we got a calculation question. So teacher just want to establish that. So yes, this is PbO. Now, salt P is a white solid. What is a chemical test to verify the anion in the present in the salt? What is the anion there? I just told you. What is the anion in salt P? Very good. It is a nitrate ion. Good. Okay. If possible, teacher would like everyone else as well to type. So at least I know that you know what you're doing. In case result comes out tomorrow, it will benefit you. Okay. So I want everyone to establish, you all know that this, in my salt P, I have a nitrate ion. All of you do know that my salt P is a nitrate ion. If you do know, type 1. If you don't know, type 2. Okay, so some say yes, one say yes, one say no. 1, 2, 1, 2, 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Okay, so you don't know why my salt P has a nitrate ion? Okay, very simple. Can you see there's a brown gas here? And can you see that when salt P has been heated up, I've got 3 products. When salt B has been, when any salt, if I heat it up and I got 3 products, it must be a nitrate salt. Only 2 salts can be heated up. Mommy wants water. Only 2 salts can be heated up. Is a nitrate salt or a carbonate salt. Okay? And if I heat up a nitrate salt, teacher will get 3 products. If I heat up a salt and I get 2 products, it is a carbonate. For example, lead carbonate. Teacher will get PbO and CO2. Now, all those of you who put 2, 2, 2, 2 just now, do you understand now why it is a nitrate salt? If you do understand now, all right, thank you. Now, then this is a very famous question, the second one. Okay, thank you, sweetie. How do I verify the anion present in the salt? How do I verify a nitrate salt? You did this with teacher. I did it for you in class, so all of you got.
Brown ring test.
Very good. It is a brown ring test, okay? So I'm just going to show you the answer straight away, so we don't waste time. Okay? So there are many ways to answer this question. Are you looking at my marking scheme now?
Yes, sir.
Okay. Now, if you're looking at the marking scheme, actually for point number 1, I don't like the way they answered. Point number 1, teacher will say, add 4 2 centimeter cube of salt solution. So this is the mistake. Students always forget. I go back to the question. This is salt P. Now, salt P is a solid. If you don't add water to it, you cannot do the experiment. That day when teacher did the experiment with you, it was a solution, right? Did I give you any solid? When you all did the brown ring experiment, did
No,
I
sir,
give
no.
you any solid? Was it all solution?
Yes.
Solution. Okay, so point number 1, you must say, for 2 centimeter cube, please give me specification. How much? For 2 centimeter cube salt solution P. That's my first mark. Okay. Then my second mark, remember when you are doing nitrate salt, if you remember, whose face was it? Aaron's face. For a nitrate salt, you're going to use Aaron's phase. You're going to use dilute sulfuric acid. You're going to use iron 2 sulfate, and you're going to use concentrated sulfuric acid. Have you all memorized this? I think this is important. Have you all memorized it already?
Yes, sir.
Okay. Some say one, I think one said yes. The rest of you, have you memorized it or not?
Yes, sir.
Okay. All right. So, number one, make sure you put that 2 centimeter cube of salt solution P is poured into a test tube. That's your first mark. Into a test tube. TT here is test tube, yeah? Point number 2. Add the first thing here. Add 2 centimeter cube dilute sulfuric acid into the test tube. Okay. Point number 3. Add the next one. Add iron 2 sulfate into the test tube containing the mixture. Point number 4. Add concentrated sulfuric acid. Now, this one, if you don't add these words, you won't get the mark. Drop by drop. Okay? Or you can say add carefully into the test tube containing the mixture. Then you can say a brown ring is formed. Okay, then you would get your answer. Okay. Namata, are you okay with this question, Namata? You're asking for page 24. Did you also want the calculation, Namata? Because calculation, I think you all can figure out on your own. No need to waste time for the calculation. Yeah, calculation can do. Okay, so teacher won't waste time. This is a typical rate of reaction question. Typical. They can give you this. They can give you chicken, small size chicken satay size. They can give you chicken big size. They can ask you which one will cook faster. Okay, so you
Small
must know. Sorry?
Small one.
Okay, so let's do this answer first, okay? So in diagram 1.1, sugar will dissolve faster where? Okay, sugar will dissolve faster in glass P, correct or not? If you look at the answer straight away.
Yes, sir.
Okay, glass P. Okay, because the size of the sugar is smaller, the total surface area exposed to water is larger. So when I'm talking about the size of the chicken is also the same, or satay or whatever they give you. Okay, it's the same. Except that maybe for this question, you will say that smaller size can absorb more heat. This one is a different marking scheme. More heat compared to bigger size. Okay. For John. All right. All right. Any questions that you want to ask so far? Can you all do? I think all these questions. Okay. 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 Collision theory here. Let's look at set 1 and set 2. You tell teacher. What is the difference here for the collision theory? What is the factor? Very good. Okay, I got copper 2 sulfate solution. Okay, this is last year's Form 4 question. Okay, I'm giving you all last year's Form 4 question. So it's quite simple, quite easy. So if you all are able to do it, actually it's quite good for you all. Okay. Okay, so this one, one of the friends asked teacher just now, teacher, how to do an energy profile diagram? Okay, so an energy profile diagram is something like this. This is for an exothermic graph. An exothermic graph, your reactant is higher than your product. An endothermic graph, an endothermic graph, okay, your reactant is lower than your products. Okay, but most important of all is they want you to label. If I have activation energy and without if I have catalyst and without catalyst. So the EA here is without catalyst, and the lower activation energy here is with catalyst. So this is what they call an activation energy profile diagram. Energy profile diagram is different from energy level diagram. Okay, the other one that teacher always teach you is like this. But I don't think you have learned it yet. Have I taught you thermochemistry? Not yet. So you haven't learned this yet. Okay. I think that's it. Okay. Anyone has any questions that you want to ask? I've covered a lot. I don't know whether y'all could cope up with everything, but does anyone has any question that you want to ask? Read also neutralization. Okay, maybe just go through. What is the formula for neutralization?
MV over MV1 over MV2 equals to A over B.
MV1.
No,
Okay,
MAVA over MVVP equals to A over B.
correct. Okay, so you must make sure. Okay, so neutralization, teacher is using MAVA over MBVB is equals to A over B. All coming to my place here. Okay, how about dilution? What's the formula for dilution? All of you busy playing on my board, but no one can give me the formula for dilution. What's the formula for dilution? Is someone planning to write? Yes, thank you, Tava. Finally, someone writing. Okay, M1V1 is equals to M2V2. Okay, so please remember this is the formula for neutralization. If teacher is using phenolphthalein, the phenolphthalein changes from what color to what color?
Light pink to colors.
No need to put light lah. So just pink to colorless, it's already fine. Okay, you still have time, huh? Now it's 5 o'clock. Is Jerry still in the class? Is he still here? Is he still counting down for me?
Yes, Chair, I'm still here.
Okay, all right. So you have got 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7. You've got about 14 hours to still study very hard. You've got plenty of time, lots of time. Okay, and I tell you, if you really do this paper and you really go through the questions teacher gave you and go back and study, go back, you still got at least 10 hours to study. Okay, you still can do it. Okay, I'm going to close unless you all want to write something. Anybody wants to write something anymore? I also never knew that y'all. What are y'all doing? Actually, y'all are just going round and round. What are y'all doing? Are y'all writing anything? Okay, this is the funniest thing ever. It's like particles moving around. All right, let me just stop this whiteboard. Okay. All right, I will let you go. Hopefully that was helpful, the class. Send in a reflection to teacher of what you learned today. If you want to go and study, teacher also don't force you. But most importantly, you still have 10 hours. That 10 hours is a lot of time. Whatever I've taught you now, you still can take it and you can go and pursue and try out and make sure you've memorized a lot of marking scheme answers I gave you just now. And what you think that I've taught you and you haven't covered yet, you still got time to cover. So teacher hopes that you all will be able to do it, yeah? I wish you all the best for exam tomorrow. So sad that it's right after your holidays. But yeah, I'm sure you all can do it. I'm
Thank you,
gonna
Chair.
add, sorry?
No, I say thank you, Chair.
Yeah, y'all can more than do it